problem 8, once again, we'll set up our statement reason column. Right here, the information that's provided is, again, our first step, that dA and dB are equal. So here's dA and dB. And then also, in this case, angle 1 and angle 2. I'll write congruent since we're dealing with the physical elements themselves. So angle 1 and 2 are equal as well. Okay, so there's our given information. And what we're looking to do is prove that AC and BC are congruent to each other. Okay, so in looking at that, if we had two different triangles, or if we had this, if we cut this into two triangles and we could show the triangles are congruent, AC and BC would be. However, we don't have that. So we can't rely on that relationship. There is another relationship that allows you to say that two sides of a triangle are congruent, and that is if it happens to be what type of a triangle? An isosceles. So if we can show this as an isosceles triangle, well, in an isosceles triangle, sides are equal, but we also know that if in a triangle, if angles are equal, then the sides opposite those angles are as well. So that's the thought as far as kind of building it back or breaking it down to see what we have to do to reach this conclusion. And so we need to be able to show that this whole angle CAB and this whole angle CBA are equal to each other. Then we can state that the sides opposite them are congruent. So we have the parts 1 and 2 equal already. That was given. Is there a way to show that angles 3 and 4 are equal? If you look at the small triangle ABD, what kind of a triangle is that? It is isosceles, right? They already gave us that those two sides are equal. So what do we know about the measure of angle 3 and 4? Those angles are equal to each other? Good. And so the justification is that the angles opposite equal sides are equal. Now this relationship is true only in triangles. Okay, so you can specify that if you want to, but it's in a triangle, angles opposite equal sides are equal. So we know that angle 3 and angle 4 are equal to each other. Okay, well, I had mentioned before, in order to show that AC and BC are equal, we need to know that CAB and CBA, those two large angles, are the same. So we do need to introduce those into our proof. So the only thing you know about angle CAB is it's made up of what parts? CAB is the whole made up of parts 1 and 3. Okay, and what justifies that? What was that called again? Again, going back a couple chapters. Angle addition. At the same time, we can introduce measure of angle CBA. It's going to be the sum of the parts, angle 2 plus angle 4. Okay, it's the same justification, so we can keep it in the same step of our proof. Okay. So now again comes a part where you have several different ways that you can go about manipulating these. Okay, here's one possibility. Now, again, I'll show you both. One possibility is if we could turn one of these statements into the other, then we can show that CAB and CBA are the same. What that means is, let's say I took this statement right here, angle CBA, but instead of saying it's equal to angle 2 plus angle 4, what can I replace angle 2 with? What is angle 2 equivalent to? 1. So I could replace that with an angle 1. And what can I replace angle 4 with? It's equivalent to 3. Okay, so if I make those two replacements, what's that called when we justify a step in a proof? That's just straight substitution, which now, once we get to that step, we now have these two things, CBA and CBA, or we have two things equal to the same thing. Oops, let me go back here. We have angle CBA and angle CAB. We have these two different things that are equal to the same thing. Therefore, what do we know about them? they're equal to each other. So CAB is equal to angle CBA. And again, what was the justification? If two things are equal to the same thing, they are equal to each other. So that's transitive property or substitution. Okay, so we can make this statement that those two angles are equal. And then if we have that these two large angles are equal, then what do we know about the sides opposite those? So now we have our statement that AC and BC are equal. And the reason for that is, again, now it's just the reverse of this, which is in a triangle, sides opposite equal angles are equal. Okay, now, again, let me go back and show you the alternate form of this. Instead of step 4 being what it is, there's another option. And that other option is, if we were to, again, let me go ahead and think of this in terms of its equality. So if we had the measure of angle 1 equals the measure of angle 2, and we have angle 3 is equal to angle 4. Well, if we took this whole first equation right here, and we said measure of angle 1 is equal to measure of angle 2, okay? And then in order to get a form that's similar to this, that would allow us to substitute in CAB here, I need to add an angle 3 to one side. So if I added an angle 3 here, so plus measure of angle 3, in order to balance this equation, I need to add either the same thing or its equivalent. Well, what's equivalent to angle 3? Angle 4. So I could use this as my step 4. If I did that, what would justify that step? What did I do to both sides of this equation from statement 1? If equals are added to equals, then the sums are equal, so that is addition property. Okay, so we could have had our step 4 be angle 1 plus angle 3 equals angle 2 plus angle 4 by addition property, which would then give us step 5 would be the same step. We take angle 1 plus angle 3. Well, what can we replace angle 1 plus angle 3 with? What's it equivalent to? CAB. And what can we replace angle 2 plus angle 4 with? Its equivalent is CBA. And so that would just be straight substitution. Okay, so again, instead of being transitive property, this would just be straight substituting in two things for their equivalents. And then everything else would fall into place, or the step 6 would still work. So you could have replaced these two, step 4 and 5, with this green step 4 and 5 in that particular proof.